Hello, Algebra 1. Well, today we're looking at lesson 2.5, writing equations in slope-intercept form. And there you can see our objectives. We're going to write equations in slope-intercept form. We're also going to apply a real-life situation to slope-intercept form, which is pretty cool. But yeah, slope-intercept form, just a reminder, y equals mx plus b. Something I've noticed with Algebra 1 students is sometimes they think, oh, I need to find out what x and y is. No. You're writing an equation. You're going to have x as a variable and y as a variable because they're constantly changing depending on what you use for your input. So what we do need to find, though, is we need to find m and b because they're going to be consistent for your line. So we need to find those out, figure those out. So yeah, sometimes you'll be lucky and they're just going to tell you what m and b is. M is slope, b is the y-intercept, and you just get to plug them in. You're going to like it when they do that because it makes it pretty simple. Nothing to calculate, nothing to compute. On this next one, same deal. Now in this case, slope was 0. 0 times x is 0. 0 minus 2 is negative 2. So what I like about this example is it shows you that, hey, when your slope is 0, you just have a y value. And we've learned that when you just have a y value, it's going to be a horizontal line. So yeah, horizontal line has 0 slope. If this is our x and that's our y equals negative 2, would be right there, horizontal. So I thought that's cool to see that. We can also look at graphs to find our slope and our y-intercept to do slope-intercept form. And it's nice to remind you that the y-intercept is where the graph crosses the y-axis, and the line crosses the y-axis right there. So our b value is negative 3. But our slope, we're not given directly, but since we have the line, we can think about rise over run. If we were to start at this y-intercept and go to the other point that they designated, we would go up. Let me double check they're going by ones. They are. Up 3. So up, hold on, what is that? 1, 2, 3, 4, 5, 6. Yeah, up 6 over 1, over 4, up 6 over 4, rise over run. And if you notice, that reduces. 3 times 2 is 6, 2 times 2 is 4, so the 2's divide out. We get 3 over 2. And now we can write our slope-intercept form as such. Now you might have noticed it also crosses there at the x-intercept, in which case we've gone up 3 over 2. Same deal, right? Same slope. It's kind of cool. All right, so for the second one, I would like for you to try this one out. And in class, I came around and checked, but yeah, pause the video, try it out, and then see if you're correct. All right, so our y-intercept is at 2. And our slope, we're going to have to go down. So that's down 3, negative 3, over 1, 2, 3, 4. Our slope is negative 3/4. Negative because we're going down. Now you might be saying, well, Mr. Eichen, I started here and I went up 3. Well, yeah, that would work too. You go up 3, but then you got to go left 4, and left means negative 4. So either way you slice it, you're going to have a negative slope here. And you've got y equals negative 3/4 x plus 2, like so. Okay, the third way that we're going to look at for writing equations is you have a line as long as you've got 2 points. 2 points is enough to establish a line. So we're given 2 points and we're asked to write an equation for a line that passes through it. Well, we are in luck here because this right here is our y-intercept. Your y-intercept is where x's value is 0. Y-intercept here was -3, x's value is 0. Y-intercept here was 2, x's value is 0. Our y-intercept is -1, but we still don't know our slope. Well, good news, we, in a previous lesson, learned the slope formula, y2, I'll write it out, but I seldom actually write it out. y2 minus y1 over x2 minus x1. I just remember subtract the y's on top. Doesn't matter where you start. I'm going to do 5 minus a -1. Then from there, do the same order. So I did 5 minus -1, so I got to do -3 minus 0. You got to be in the same order or else your sign won't be correct. So this will be a 6 on top, a -3 on the bottom, which is -2. And that means our equation is going to be y equals -2x minus 1. And for part B, same deal. Again, if you're in class, I would have you try it out and see what you get. So I would encourage you pause the video and then play it after you have figured it out. All right, so our y-intercept is -5. Our slope is going to be -5 minus a -5. And then 0 minus 8, that's the way I decided to do it. Oh, check it out. We get 0 over -8. Well, 0 divided by anything is 0. And then from there, we write y equals 0x minus 5. But we've seen this already, haven't we? The 0 wipes out that x. We're left with just y equals -5, which would totally be a horizontal line. Yeah, all right. So moving on to the back. We've got function notation. Now, I know we've been struggling a little bit with function notation. Don't think I haven't noticed, all right? But function notation communicates input and output values at the same time. It's saying the function's value when the input is 0 is 10. So this is the input, this is the output. Well, that's the same as writing a coordinate. X is the input, Y is the output. X is the input, Y is the output. So this is really no different than what we've been doing, and hopefully it helps you to understand function notation a little bit more. So we've got our y-intercept, our b is 10. We got to calculate our slope. 34 minus 10. Since I did 34 minus 10, I got to do 6 minus 0. And 34 over 6, I think... Oh, I'm sorry, it's not 34, is it? Yeah, sorry about that. 24. Yeah, 24 divided by 6, that's a little bit easier. That's 4 is what that is. So our equation is y equals 4x plus 10. Now, class, it did say to write a linear function f. So they actually wanted us to name this f. And they named it when they gave us the coordinates too. So take a moment, rewrite this as f of x equals 4x plus 10. F's value depends on x. And there we go. All right, so for this next problem, we're gonna do some modeling with mathematics. It says in 2003, a gallon of gas cost $1.75. In 2013, a gallon of gas cost $3.50. Well, class, I'm seeing input and outputs there. I'm seeing coordinates. 2003 corresponds with $1.75. 2013 corresponds with $3.50. But let's read our instructions here, see exactly what they want us to do. They want us to write a linear model that represents the cost in dollars of a gallon of gas. That's no surprise, I could see that. The outputs appear to be the money, so cost. But they want us to write it as a function of the number of years since 2003. Well, class, this is actually going to make this problem make a little more sense in a way. 2003 is going to be now our starting point. It's going to be our y-intercept. So in 2003, the cost is $1.75. Well, since 2003 reverted to zero, because it's 0 years since 2003, 2013 is actually how many years since 2003? Yeah, it's 10. It's 10. So at 10 years, fuel cost $3.50. Well, class, what we can do is we've got our y-intercept. That's cool. There's our b right there. We just need to calculate the slope. Subtract the y's on top. Subtract the x's on the bottom using the same order that you did for the y's. And because we have decimals, I'll go ahead and get a decimal answer here of 0.175. So our equation is, I'll just call it, yeah, I could go like cost. Cost of a gallon of gas is equal to 0.175 times t, which is the number of years, plus our y-intercept of $1.75. You could write it like that, but yeah, you could do y's and x's. But this is going to be the cost of the gallon of gas, and this is going to be the years since 2003. Yeah, cool. That's our equation. The beautiful thing about writing equations is then you can, since you got like a formula, you can use it to predict things in the future or to go back to the past and predict what the situation was in the past. So if we were going to go into the past, we would be trying to figure out the price of gas, in 1995 or something like that. But what they're wanting us to do is to extrapolate the data forward. They're wanting us to find out, to predict the cost of a gallon of gas this year in 2023. Well, to do that, we got to be careful because the temptation might be to put 2023 in for T. But that would be too much. We need years since 2003. So that means our T value is going to be 20. So we go cost is equal to 0.175 times 20 years since 2003 plus 1.75 and beep-boop-bop-beep, $5.25. So it turns out this model kind of overshot it a little bit. Gas is around $3.40 locally. So it overshot it a bit, but that's the thing. Gas prices go up and down. It just kind of depends. It used to depend on just a few oil manufacturers, and OPEC used to have a big, they would artificially adjust prices and things based on how much oil they were pumping. But anyway, OPEC doesn't have quite as much of a hold on everybody's gas prices as they used to, not quite as much. Anyway, that's neither here nor there. You've got a handout for some practice. Have a good day.